of course, RTP uses the IP layer, so there are probably plenty of IP hops in between. And let's further assume there's an attacker on the IP layer here that wants to attack the communication, or at least the authentication between Alicia and Beyoncé. So what happens is, we look here at the communication. Here we have the two. If Alicia and Beyoncé establish a Diffie-Hellman key exchange, the attacker can, of course, launch a man-in-the-middle attack. Now what ZRTP does is, it really displays the hash of the messages in the display of the phone. So Alicia, for example, her phone sent message 1 and received message 4. So the phone can display the hash of message 1 and 4. Now on the other side, the phone of Beyoncé received message 2 and sent message 3, so it can display the hash of message 2 and 3. It's called the short authentication string. And obviously, if there isn't an attacker, the hash should be the same. Now, if there is an attacker, this hash will not be the same as this one. And now the key idea here with ZRTP is that the phone displays this hash, and the communication partners can read this within the RTP stream. Now, if an attacker still wants to launch a man-in-the-middle attack, he would need to parse the real-time conversation in real time and act accordingly. And this is the key idea here. So it's kind of using the fact that computers cannot parse messages or graphics as much as text. It's kind of the same as these capture things that you have on Yahoo Mail and stuff. So this is the key idea here behind ZRTP. Now there's a prototype implementation. It's called ZPhone by Phil Zimmerman, and you can download it, use it. And I've just shown it, taken it here to show you that you see here actually the short authentication string, and you can read it to your communication partners. So this is also really easy to use. People who are not familiar with security, they get displayed the string, and they can say, hey, well, what do you see? And the communication partners can exchange the string, and if it's the same, they can assume that there's no man-in-the-middle attack. If they don't know what a man-in-the-middle attack is, they can at least assume it's secure. So this is the idea. But there are other approaches. Within the IETF, there's an approach it's called identity assertion, which basically means the domain asserts the identity of the zip users in this domain. So again, here we don't see the domain, but this is Alice's domain, and this is Bob's domain. Now, if Alice wants to send a message to Bob, she sends her invite, and then her local proxy challenges her and says, well, prove that you're Alice. And if the challenge is answered correctly, then the zip proxy will verify that identity, assert the identity, and sign this assertion. And then the invite message gets forwarded to the zip proxy in Bob's domain. Now this proxy then can verify the assertion and forward the message to Bob. I put here an RFC and some references. You don't need to write these down. They're all in the paper that you can download from the conference website. Now, if you think about this closely, it is a nice idea that only the domains need some key exchange and everything, and not every communication partners. But we really have the same problem. We would need a worldwide PKI for all domains, and also we would need some way that this proxy here, if it verifies the assertion, this proxy really doesn't know what happened here. I mean, it knows that this domain signed actually Alice, but it doesn't know anything about how this domain really verified the identity. It can be, I mean, we all don't know this from HTTPS web pages. There have been always certificate authorities that sign everything. So, I mean, if there's a domain that signs everything, that doesn't help us much. Okay. One last thing about authentication is I just want to mention this briefly, but this is another development. There are people in the zip community that have realized that TLS is, for some scenarios at least, not sufficient. You really have to think about this closely. If you're familiar with TLS and HTTP, how it's used in HTTPS, there's only one hop on the application layer. There's your client and your server, and on the application layer, it's just one hop. Now, if you think about zip, there are many hops on the application layer. So this brings up new issues. There might be intermediate hops that are not trustworthy. And of course, also all these application layer hops need keys between each other. So there are efforts underway that try to develop something new. Here I put the internet draft up here, but it's also, of course, in the paper if you're interested. That's further reading. Now, another problem that's been catching much attention is, of course, spam over IP telephony. Now, what is this? SPIT is the abbreviation for spam over internet telephony. And if you think about it, it's really different than email spam because voice over IP is a push technology and email is really a pull technology, meaning a voice over IP message I get will most of the time have my phone ring. So this is much more annoying than email spam. And because it is real time, that means that any content filtering, which is a very successful technique for email spam filtering, cannot be applied so easily for voice over IP. So we really need something else here. And of course, what you have to realize is that still the automated generation of spam messages is feasible for attackers. So it can be assumed that this will become a problem. So what can we do? One thing we can do is we could install something what's called a reverse Turing test, which is basically a machine trying to determine if the communication partner is a human or a computer. So a machine that asks the caller, what is 5 minus 2? And again, here the assumption is that an automatic spam computing machine cannot parse this conversation in real time, and thus cannot react, but a real communication partner can. Of course, there are problems with this. There are language problems, old people. I tried to find something other than old people, but I didn't come up with anything. But it is a problem for old people. Let's put it this way. What? So, yeah, it can be a problem for old people, but I was trying to think of other people for whom it...
My wife's family's Korean. If they call and they get a question in English, they won't understand.
Right, that's the other point I have here. The language is really a big problem too. So there are problems. Of course, another big problem is urgent calls. If you're in a hurry and you're shaky and you're nervous, like I'm right now, and you want to make a call, and then there's this machine saying, well, what's 18 minus 5? And you type in the wrong digit, and you know, and you get hectic. I mean, we all know this. So it might not be the best idea. Another thing that we can use, and I mean, many people have suggested it also for email spam, is a micropayment system. If we would have a micropayment system today, we probably wouldn't have that much email spam, because what email spam really, why it works is because sending an email costs nothing. So you can send 2 million emails and it doesn't cost you anything. And that's the same problem for voice over IP. So if we had a micropayment system, which of course we don't have today, but if we would have one, this could help us against fighting SPIT. Of course, if we had standard authentication, and I've just shown you that we don't have it today, but if we will eventually have it, this would help fight SPIT. It wouldn't fully solve the problem because of the reasons I've just shown you on the other slide. Even if we have signatures and assertions, we don't know what other domains use to verify identities. So as long as there are some huge domain out there that doesn't correctly verify identities, we only have the choice of blocking all calls of that domain, or we end up in trouble. So this is not a full solution. And another idea that can be used, and which is quite interesting, is what's called computational puzzles, meaning that each time you want to make a call, or at least your machine makes a call, it needs to solve some computational problem that causes CPU time, causes memory, which takes maybe 2 or 3 seconds. Now this is not a problem for regular call behavior, but it is a problem for spammers, because it means that a spammer then would need much computation power, so it makes it expensive for him. If you're interested in zip and spam, there's an interesting internet draft. Again, this is in the paper, where you can find some other ideas and get some insight into the problem. Now there are SPIT prevention implementations out there. Most of them are proprietary and not public. But this was one example I've chosen from NEC Europe, where they've published what they've done. I don't want to get into the details here. They've implemented it in a Zip Express router, and they use Turing tests and user feedback. So user can then say, well, this was spam and not, and also train the machine. If you're interested in this, Saverio Nicolini, who developed this thing, will talk about their SPIT implementation, or their SPIT prevention implementation. They're not doing SPIT, they're trying to prevent it, actually. And that's at our seminar in Hamburg on February 1st. So if you're in Hamburg, last time I tried Google Nicolini SVS. SVS is the group I work at. The first link was the details of the talk. But if that doesn't work anymore, you can send me an email. If you're interested, just come. Of course, this is a joke here. It's public, right? You can come to the talk. Another problem. Well, yeah, it's a problem. Let's put it. It's a problem. It's lawful interception. If you don't know what the term is, who knows what lawful interception is? Well, that's plenty, but not all. It's basically legalized eavesdropping of communications by a government agency. And at first you might say, well, do we need this at all? We have it today. It's successfully used in the PSTN and in GSM networks to capture criminals and prosecute them. So there are reasons why we want this, and most countries have some laws that allow this. Now, I just said that it works fine in the PSTN and the GSM, or mostly fine. But for lawful interception of voice over IP, there are some additional problems. First of all, if you remember the first slide I've shown you, the first picture, usually the voice over IP provider and the internet service providers are different entities. So your real-time stream goes over different routers, also than your signaling. So the law enforcement agency really needs to intercept traffic at 2 points here, at your zip provider and at your ISP. Also, I've just said that signaling and payload take different routes, and of course we can have encryption. So nevertheless, there are standards being developed right now. There was also an interesting talk about lawful interception of voice over IP last year at the conference. If you haven't seen it, you can maybe download it. So standards are being developed, and there's much controversy on this. I've just recently read that not only the Swiss government, but also German government considers developing Trojan horses that get deployed in the machines of the users they want to survey. So I think this is really dangerous. I mean, think about this. This really means that the governments develop malware to catch criminals. I mean, okay, they need to do this because the technology is so complicated, but is this the way we want to go? I don't know, I just feel it feels strange to me that governments develop malicious software.
RFC 1984 actually explains by IETF why this shouldn't be done.
Why this shouldn't be done?
Yeah.
On the next slide I have also some arguments why this should not be done. Okay. Okay, well, good reference. I will read this because what I just said is I feel shaky about it. Maybe there are some good arguments there. Also, lawful interception will impose costs for this new industry. So there's some criticism there too from that side. And there's a famous paper that some famous security researchers have written. I'll give you a minute to read this. What you need to know is CALEA stands for, I always forget what it stands for, Communications Assistance to Law Enforcement Act, and that is basically the US law for lawful interception and communication surveillance. And yeah, well, recently the FCC has thought about how this can be applied to voice over IP, and they've seen that this causes problems. And these researchers really think it's not the right thing to do. And I think what a key word here is they feel at least it's an architectured security breach. So there's much controversy. If you're interested, read this paper. It's really good, and it gives you a good overview of what's going on, why this is good or why this is not good. Okay. So our next topic is testing zip devices. Why do we need this? I've already, in the introduction, I've said that zip devices are more complex than traditional telephones. So we need some way to test these, and because hard phones usually are not open source, we probably need some black box testing here.